Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civi, and today I'm going to discuss the different type of VAV box controllers. There are 4 different types of controls that you can get on a VAV box: electric, pneumatic, analog, and digital. Before I go into the descriptions of the different types of controllers, let's do a quick refresher on VAV box control components and how they work together. So let's draw a single duct box. Here's the inlet and the casing. Draw on a control box. Okay, so there's a flow sensor in the inlet of the box measuring the flow. Inside the control box there's an actuator that opens and closes the damper, and a controller that controls the actuator's operation. Somewhere in the room there'll be a thermostat, and the thermostat sets the set point and measures the room temperature. So say you have a set point of 75 degrees and your space is 78 degrees, it sends that information to the controller. The controller then says, hey, we need more air, and it'll send it to the actuator to open the damper. This whole time the flow sensor is measuring the airflow in the box so that it gets the right amount of airflow regardless of what the pressure is in the system itself. So that's a super simplified view of the operation of the controller, actuator, flow sensor, and thermostat. Obviously you can have reheat and other things controlled by the controller, but that gives you the basic idea. The simplest control system is electric. It's also the least used control type. An electric control system is a low voltage system using 24 volts AC. In an electric control VAV box, you only have a thermostat and an actuator. So let's put a thermostat over here, and we'll put an actuator on the damper shaft. Let's draw in the rest of the box real quick. So the actuator is just going to open and close the damper, and it's just getting a signal from the thermostat. So when the thermostat senses a reduction in temperature, it drives the actuator closed. There is no flow sensor in an electric VAV box, so an electric VAV box system is pressure dependent. This means that changes in system pressure will change the amount of airflow you get out of your box. Because of this reason, electric systems are likely to have large room temperature variations, and they're not used very often. The next control type is pneumatic. They were the most popular control type when VAV boxes first gained popularity. Pneumatic controls require a compressed air system, so we don't see a lot of new pneumatic buildings being built, but there are a lot of existing systems out there, so we see a fair amount of pneumatic VAV boxes still. Many universities and hospitals use pneumatic boxes as well. In a pneumatic system, the components are powered by compressed air, usually 15 to 25 psi, from a main air system. So let's draw a single duct box again. You have a main supply air that supplies all the pneumatic systems in the building, a thermostat, and then on the box you have a controller and a pneumatic actuator, and in the inlet you have a flow sensor. So the main air system is connected to the thermostat and the controller. The controller is also connected to the flow sensor and the thermostat, and it's connected to the actuator. The thermostat receives full air pressure from the main supply air, and it modulates the output pressure that goes to the controller to tell the controller whether it needs to open or close the damper. So when the room sensor senses an increase in temperature, the thermostat output pressure increases as well to the controller, which tells the controller to open the damper and supply more air to the space. Pneumatic controls can be pressure dependent or pressure independent, but we usually see pressure independent. We'll have a future podcast that covers more detail about pneumatic controls, since we still see them around and a lot of people don't fully understand their operation. Next we have analog controls, also known as analog electronic controls. They're 24 VAC controller, and they operate in a standalone configuration only. They have very easy setup, using just the thermostat to set up your CFM and all the parameters you need. So it works something like this. Let's draw a box. Put in a flow sensor in the inlet, a controller and an actuator in the control box, and then a thermostat somewhere in the space. This thermostat is connected to the controller, as is the flow sensor, and the controller drives the actuator just like we've been talking about. Analog controls tend to be a very cost-effective controller when you just have one or two boxes that you want to control in a building. And finally, we have direct digital control, also known as DDC controls. They are also 24 VAC controllers. They can operate as standalone, or they can be put on a building management system, a BMS system. So let's draw another single duct box. There's a flow sensor in the inlet, and then you have a controller actuator combo usually. There are some models that are two parts, but frequently they're one combo unit now. And then a thermostat on the wall somewhere. Again, the thermostat is connected and the flow sensor connected to the controller, which drives the actuator. The difference here from analog is that there's a building management system somewhere, so there's a computer running software that is connected to this VAV box controller and also to multiple VAV boxes so that you can see your entire system sitting in an office somewhere or maybe off-site. DDC controls are the most common controls we see today. So that's a quick overview of the different types of VAV box controls. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.